So I have to crouch like this when I talk. I'm sort of like on a little bit of a crouching position at the moment. I'm not crouching, I'm standing. I'm just having to bend down a little bit. That's what I mean. But today we are going to look at the concept of optimization in one particular way. We are going to look at just one problem today. We are going to be looking at the maximum area of a rectangle within an unwell drawn circle. This is supposed to be a circle. It is going to be defined as a circle, but I'm really bad at drawing circles and curves. Like, I don't even know why. So let's call this circle x squared plus y squared, and let's give it the radius of 1. 1 squared is 1. So 1 squared. And let's denote this rectangle. It's not a perfect square. It is supposed to be a rectangle. Let's denote its area. Its area as x multiplied by y. And now what we can do is we can optimize this function into this function, and we can find a maximum area given the circle's constraints. So how will we go about this? Well, we've got a y here, and we can rearrange for it, and that would give us plus or minus the square root of 1 take away x squared is equal to y. Hopefully you guys can see that. This is my first time using the whiteboard, so hopefully it's alright. And from this, we can put this constriction into this equation, and that gives us area is equal to x multiplied, we're going to look at the top half first, multiplied by 1 take away x squared. Okay? So that's our function for area, given the constraint of the circle. Of course, at this point, we're just looking at the top part of the circle. So whatever we get, we have to multiply by 2 to get the full area of the square. Okay? So now, what's the next part? Well, the next part is to differentiate. So let's go ahead and do that. Let's call this a prime is equal, using the product rule, we differentiate this first and we get the square root of 1 take away x squared. And then we differentiate this second, and that gives us x over 2 root 1 take away x squared multiplied by minus 2x. Okay? So that is the equation for our derivative, and to find a minimum or a maximum, we have to set this equal to 0. So we get that 1 take away x squared plus x minus 2x squared, minus 2x squared, all divided by 1 take away x squared root over 2 is equal to 0. And the 2 cancels with this 2, so, and if we multiply by 1 minus square root of 1 minus x squared throughout, we get 1 minus x squared plus x squared minus x squared is equal to 0. This is plus minus x squared. And that gives us 1 minus 2x squared is equal to 0 right there. And now we have to rearrange for x to see what our maximum or our minimum could be. Now I'm on my knees, and I don't know if you guys can see me, but let's go ahead and do that. So we rearrange and we get 2x squared is equal to 1, and we get x squared is equal to 1 over 2, and we get x is either equal to plus or minus 1 over root 2. Okay? So those are what we call our extreme points. Now we have to find a value of y as our first thing we have to do, and then we have to interpret the answer. So we had an equation for y over here. That is what we plug our x we found into. So let me make some room here by getting rid of this diagram. So you guys should be able to see this little part. Yep. Whoa, nearly fell over. So now we just plug in that value. We get plus or minus 1. And because this is squared, we can just take the positive and it will give out the same result. We get 1 take away a half. Okay? We get 1 take away a half. It would be 1 over... Sorry, it would be square root of 1 take away 1 over square root 2 all squared. But the square cancels out with the square root, so we get this. And therefore we get plus minus 1 over 2. Which is essentially 1 over root 2. Okay? That was a really bad way of writing it, I must say. So, the points are, we've got plus or minus 1 root 2 by plus or minus 1 root 2. But what is the maximum area? Well, if we put these back in here, well, we get the area, the maximum or the minimum, that being said, is equal to 1 over root 2 plus or minus multiplied by plus or minus 1 root 2. And that gives us 1 over 2. That is supposed to be in there. Okay? So the area for any of these possible x's, these ones, will still give a half for the area of our rectangle. But because x is equal to y, what can we denote that as? Well, we can denote that as being a perfect square. Because we have 1 over root 2 and 1 over root 2 as our lengths. Okay, and that is it. Now we want to justify whether or not these are maximums or minimums. So the best way, you can do the second derivative test, or you can just test around the area. So the first thing that we will try, in this particular video anyway, is we'll test some values. So let's go ahead and let's look at a simple value. Let's look at 1. At 1, we get this to be 0, and that gives us an area of 0. Because area is 1 by 0, which is 0. So, absolutely, straight away you can tell, well, this is definitely less than half here. So, does that mean that this is a maximum? Let's look at one more point. Let's try and think of a nice point here, guys. Okay, I'm thinking of root 3 over 2, but that's not very nice. Let's try 1 over 3. 1 over root 3. So 1 over root 3, that will give us an output here of 1 minus 1 over 3. The square root of that is root 2 over root 3. And if we multiply that through into this formula of the area, we will get area is equal to 1 over root 3 multiplied by root 2 over root 3. And that will give us root 2 over 3. And in terms of value, is that greater, equal, less than 1 over 2? I can say that is less. So this is less than 1 over 2. So what we're saying is we've found a few points around the 1 over root 2 mark, and we've found that, hey, they're always below that value. So we can say that, yep, we can say that this here, this area is equal to a half is maximum. And that sort of makes sense. Because when you think of area, you'd think, okay, we have this circle, and if we wanted to fit a rectangle with minimal area, would go towards 0, right? We would just have 0 as a point. So yeah. That's optimization. Question 1. I might do another video on, I don't know, I might do something like maximize the area of a rectangle underneath a parabola. That's my next video. So guys, if you enjoyed this video, remember to leave a like, subscribe for more content, and I'll see you guys in the next one. Now, one thing I forgot to mention is we found the area. We found the area of the rectangle, but we didn't multiply the area by 2. You might be wondering, what? Why would we do that? Well, the description here has plus minus, but we substituted here only the plus. So basically, what we found here is the area of a rectangle within the top part of the circle. So what we can say is that the maximum area of that rectangle or square that we were looking at in a full circle is actually 2 multiplied by half. And that gives 1. And yeah, that's the actual finish of the video there.